that satisfy requirements that have been given without physically having to make a stinking list of all the different sets that are out there. That's way too time consuming for our natures in the problem. So we have two fundamental principles that we have to deal with, and I can't make it much simpler than this. The addition property of counting is going to be used when you have a union operation to perform between two sets. The issues you have to concern yourself with in that is when that union has common elements. Think of a Venn diagram when the two circles overlap. Some of the items are in circle A as well as being in circle B. That's what we mean when we say common elements. They belong to more than one of the individual sets at a time. And it's possible that your sets may not have any common elements, and not all of our exercises are done with Venn diagrams, as we're going to see today. Some of them can be done with Venn diagrams. That allows people to use the right side of their brain, the artsy-crafty side of the brain, the visual side of the brain, along with the analytical side of the brain, the left-hand side of the brain. So the addition counting principle talks about having two sets. Doesn't mean we're going to be limited to two sets all the time, but we can only work with two things at a time because we only got two hands. Now, if we were Martians and had three hands, maybe we could deal with three things at a time, but I can't juggle three things at a time as a general rule. So you have to be able to determine the number of items that are in set A. You have to be able to determine the number of items that are in set B. And then you have to, more importantly, and the most importantly thing, is to be able to determine whether there are any items that belong to both sets, because if that's the case, then you've counted those items as part of the sets more than one time, which is going to upset your numbers that you deal with out there. Okay, so this we saw this slide on Monday, so there's not really anything that's been added to that slide, but from here on out I kind of changed pretty much everything because I didn't like the way that it was flowing, okay? So if you want to be a little bit more elaborate to that, let's keep it simple. How do you know if you're going to be using the addition problem? Well, big thing, you'll only have one activity that you're being asked to complete. The instruction will say something to the effect of draw one card from the standard deck of cards. Toss a coin one time. Roll a dice one time. Select one person from a group of people. So you'll only have one blank to play fill in the blanks with. And we are going to use an approach which is kind of a fill in the blanks type exercise. So again, back to the addition property. Here's the symbolic relationship for the addition property, but there's more information in here that could be useful. What can be useful is what you'll see in your word statement. If they write it in words, you're going to see a word that says or something that can be translated to or. It might be not a club. Well, that means it could be a heart, a diamond, or a spade. So there's an or that's implied in there. It may say it can't be, it can be neither nor. Can't be this, nor can it be that. Okay, so that's a double negative on that or, so it takes care of both of them out there. So you won't always necessarily see exactly the word or in there, but the phraseology will tell you that there's more than one thing that you have to select from. Okay? Now, if that's the case, then we have only one single event. But that single event can have multiple different types of outcomes. If I toss a coin, there's actually two outcomes. It's either going to be a head or it's going to be a tail. But what if I roll a dice? That dot that shows on the top could be a 1, a 2, a 3, 4, a 5, or a 6. Multiple outcomes would be in there. What if I draw cards from a deck of cards? Could be a heart, could be a spade, could be a club, could be a diamond, could be a red card, could be a black card, could be a face card, could be something else. Lots of different outcomes. Those are the things that we have to concern ourselves with, is what are the individual outcomes that we're going to have. And that means that we have to be aware and make sure that we don't double count those common elements in there. So number of items that are belonging to set A combined with the number of items that belong to set B means you have to know how many are in A distinctly, You have to know how many are in B distinctly, but you also have to be aware of the fact that the items that's shared in both of them. In a Venn diagram, this becomes very visual. When it's not a Venn diagram, it then becomes contingent upon you being able to ferret out, to be able to figure out, are there any items that belong to each of those sets? You may ask that question and come up with a no. And that's fine, because just because you're looking for shared elements doesn't mean that there are any shared elements. Just because all the Venn diagrams had overlapping sections doesn't mean that every exercise is going to have overlapping sections. For example, there's no way that freshmen overlap with sophomores. To be a freshman, you have to have less than 30 credit hours. If you've got more than 30 credit hours, you can't be a freshman. Okay, so they're distinctly different sets. And there are other analogies you can deal with out there as well. The author likes to use standard deck of playing cards, and this is kind of where we left off yesterday, and we're going to get into deeper today. The coordinator, I've been asking for years for the coordinator to put this on the tests. But she doesn't like it on the test because that means that people that are colorblind will not see reds and blacks. So she lists them as entities, as a list type of thing rather than a visual thing. I like this, but not necessarily good for everybody. So you won't see this anywhere, but this is what a deck of cards looks like. Standard deck of cards, 52 cards, grand total. We don't consider the jokers being out there. Subdivisions, ways to be able to sort them out. You can sort by suits, which means there's going to be 4 suits: hearts, diamonds, clubs, spades. Each of those suits is going to share the same number of cards. So 52 divided by 4 gives you 13. So there's 13 cards in every suit. Some questions may say, how many ways could you get a heart? Well, you know there's only 13 possible hearts to pick from. Okay? So 13 cards per suit. 2 different types of colors. Some of the suits are red, some of them are black. So that means 26 of each. 26 red cards, 26 black cards, which is 13 plus 13. So you don't need to carry around all these facts. If you can see the picture, you can ferret through them, but many people do carry around some of those facts in their head. There are face cards, sometimes called picture cards. That would have a king, a queen, a jack on them. And there are numbered cards. Those will be the things that have a number on them. And the ace does not have a number, but it shows only one glyph on the card. So that has to be a number 1. Now, some games count that as value 1. Some games count that as value 11. So if you're playing blackjack, that can be counted as a 1 or it can be counted as 11. If you're playing poker, the ace can be both a value that's for a run for a top end things, jack, queen, king, ace, or for a low end things, ace, 2, 3, 4. Same kind of thing for gin rummer. So we don't really look at that as being a separate entity. It's just how we use it in the problem. So this is what will show up at the beginning of your test on every test. It's at the very top of the test for test number 2, so that you don't have to remember all these things. It will be there for you. Some of the problems as you're going through the test will have a pop-up screen that comes up that tells you, that reminds you of this, so you don't have to leap back to the first page of the test to be able to find out what the composition has to be. So that's called an instructor note. And that's always available in the pull-down box that's kind of along the lines of where you see it. Help me solve this in a regular set of exercises, if the instructor's made one for that. Now, for the exercises we're dealing with, in terms of the homework, that's probably not going to be there for those, but when it comes to the test, it'll probably be there. I would like the picture up there. That would be nice, but the coordinator doesn't want to have that up there. So anyway, when they refer to cards, this is what we have to pull up in our mind, okay? The author likes card problems. He likes them really a lot, and even though you may not like cards, you may not be conversing with them,